In the previous lecture, we analyzed the most significant coefficients. We also noticed that daily workload average, distance to work, and day of the week seem to have the lowest impact, if we can even call their contribution an impact, as their weights are almost zero. Okay, so what can we do about it? There is a concept called backward elimination. The idea is that we can simplify our model by removing all features which have close to no contribution to the model. Usually, when we have the p-values of variables, we get rid of all coefficients with p-values above 0.05. When learning with sklearn, we don't have p-values because we don't necessarily need them. The reasoning of the engineers who created the package is that if the weight is small enough, it won't make a difference anyway. And we trust their work. Okay, so I say that if we remove these variables, the rest of our model should not really change in terms of coefficient values. Let's go back to the checkpoint when we created the targets. This was our last data frame manipulation step before we started standardizing. I'll take this checkpoint, data with targets, and drop the three features we were just discussing: day of the week, daily workload average, and distance to work. Let's run the code until the end. A simple way to do that is to use kernel, restart, and run all. Note that if our code is written well, such lower dimensionality of the main data frame will not cause any problems. However, if we have explicitly written the number of columns somewhere in our code, or any specific column names, then the execution will stop. Let's use the restart and run all option anyway and see what we obtain. Well, we encountered a problem. The error reads, day of the week, distance to work, and daily workload are not contained in index. The issue is that we pre-selected the columns to scale, and they were included there. We can simply remove them manually and continue running the code. However, I don't really like this. What we can do instead is augment the code by declaring a new variable called columns to omit, and create columns to scale as the difference between all columns and the ones we would like to omit. While either way the code is not completely parameterized, it seems it is more intuitive to choose the columns to omit. So, columns to omit is a list that contains the 4 reasons and education. To find the columns that need scaling, I'll use list comprehension. List comprehension is an amazing syntactic construct which allows us to create a list from existing lists. Here's what we'll write. Columns to scale is a list that contains x for x in unscaled inputs dot columns dot values and contains the following condition: if x not in columns to omit. Technically, written in this way, the list works like a loop, which looks into all column values and takes those which are not part of the variable columns to omit. Okay, let's restart the kernel and run all. Nothing happened, which means our code worked well. Checking the regression accuracy, we see a slight difference. Moreover, we can notice the number of correctly predicted instances. This shows us that the 3 variables we dropped were useless. With or without them, we obtained practically the same results. Either way, a simpler model is always preferable. All right, let's wrap up here and get ready for some testing. Thanks for watching.